quite unfortunate, but we all know that IPv4 addresses are running out. When IPv4 was created, nobody imagined a world where every human being would own multiple internet-connected devices, such as smartphones, laptops, TVs, mobile phones, and even refrigerators. The creators of IPv4 gave us 4.3 billion addresses. At the time, it sounded quite generous. Fast forward to today, when everybody has 2 to 3 devices minimum at hand, you can do the math. Quickly you will realize something doesn't add up. So the obvious question here is, how does the internet still work, and how does every other device manage to interact with every other device in the internet? That makes me wonder, was there ever a fix to this problem? Answer is yes, and that fix is called NAT. By the end of this video, NAT is going to be very clear to you. Now, what is this term NAT? NAT stands for Network Address Translation. Instead of memorizing this term, let's break down and see what it actually means and how it actually works. Imagine a typical home that has phones, laptops, smart TVs, and tablets. Now imagine this on a global scale. If every device had to require one public IPv4 address for itself, we would have run out of IPv4 addresses decades ago. Yet here we are. Why? Because not every device on the internet speaks to the internet directly. Now, what do I mean by devices don't need to directly connect to the internet or talk to the internet to get the internet services? Will a few devices pretend to be some other device and avail those internet services? Because if it has to talk to the internet directly, it will require an IPv4 address of its own, a public one. So now it's a good time for me to introduce you to a term called private IP addresses. Think of it like you have an official name on papers, on documents, and people in your office or people who aren't that close to you call you by that name. But within your inner friend circle or within your close family, you have a name maybe which is a bit goofier than your official name, and that is exactly how devices work. Consider the goofier nickname as the private IP address and your official documented name as the public IP address. So as the name suggests, public IPv4 addresses is known to the entire internet. Private IPv4 address, on the other hand, is only known inside the local network. It's for internal communication. If you look around in your house, you might notice you have something known as the router. This router gets one public IPv4 address. For any kind of device that exists in the house and that requires internet connection, now has to be connected to the router. So if you have 10 devices, having 10 public IPv4 addresses would be very exhausting. Hence, all these devices have private IPv4 addresses. But again, we are very clear with the fact that devices require public IPv4 addresses to connect to the internet. Your internet is not gonna know your goofier nickname or the private IP address of the devices. It needs to see the public IPv4 address in order to recognize the device and give it internet connection. So you might be wondering, what public IPv4 address is being used by the rest of the devices? Exactly. It uses all of those devices use the public IPv4 address that was given to the router. Now let's hop in and see how this actually works. So for example, your phone has to search for a website. Your phone will send the request to the router because that's the internet connection which is immediately next to it. And it will do so using its private IP address because that's what it has right now. The router, after receiving the request, will replace the private IP address with its own public IP address and send the request to the outer world. To the outside world, it would look like, okay, this router is requesting for this data. If I have to send the response back, I'll send it to this router. And after that, the router can redirect it to whoever it wants. And it doesn't look like, okay, this particular device in this particular home, in this particular local network is searching for a website. It looks like the router in whole, which has a public IP address, is requesting for the data. Now at home, you have multiple devices, to be honest. Do you ever feel the need to keep rest of the devices switched off when one device is online or do the same for the rest? No, right? You can have all the devices turned on at the same time, having smooth internet connection, watch videos and play games. How is this possible? So in my previous example, I had shared that one device was requesting for a website and the request went to the router. The router replaced the private IP with the public IP and sent the request to the outer world. When the response came back to the router is not confused whom to send it back to. It's absolutely connected to a lot number of devices, but it maintains something known as the NAT table. Now, what is a NAT table? NAT table is nothing but Google Sheets or a directory for the router to maintain and remember who had requested for what and whom to send the response back to. So when our phone had requested for the website, the phone's private IP was mentioned in the NAT table alongside the request, and when the response has to come back, it very well knows whom to send it back to. This is why all devices can work smoothly, seamlessly, silently at the same time without you even noticing so much is going on behind the scenes. Your internet service provider does not care about your internal private IP addresses. All it cares and takes care of is the public IPv4 address, and it needs to manage your router only for the network connection of the entire house. This entire procedure, where the router replaces your private IP with its public IP address and does the vice versa, is known as network address translation, and this is how the world overcame the IPv4 shortage. Now, a little food for thought, something interesting. We are well aware of the fact that IPv6 is coming into picture, and it's going to be providing us an unimaginable number of addresses. Would this mean that this will completely eradicate the concept of NAT, or will we continue to work with IPv4 and NAT and have IPv6 do other kind of jobs, or will the number of devices that people have will upsurge and will keep increasing, and we'll also encounter a shortage of IPv6? Because honestly, with the number of addresses that IPv6 will provide us, we can surely say that every device is going to have their own public IPv6 address and directly interact with the internet. They would not require any network address translation in the first place. Would that mean NAT will completely disappear in the future? Maybe, maybe not. We don't know. But we'll all be there to witness this change for sure. But for now, IPv4 is doing great with compatibility, security, and legacy infrastructure. And honestly, it's a pretty elegant solution. IPv4 creators truly underestimated humanity's obsession with devices and how many devices one person would own. But NAT actually came into picture, and without it, modern internet wouldn't actually exist or work. If this video truly helped you understand how the internet works and helped calm your curious mind, feel free to like and subscribe for more such videos, and go ahead and share it with somebody who loves networking.